Hi everyone, my name is Yuris and in this video we are going to talk about the true essence of vacuum. Turns out there are huge problems with the existing understanding of what is a perfect vacuum. And this understanding as it currently is as follows. Vacuum, a perfect vacuum, is completely free of any substances. But that means that a perfect vacuum is filled with, if you can even use this word, it's filled with things that physically don't exist. So a perfect vacuum is something that physically doesn't exist, and yet, according to science, it does exist. Starting probably, was it Aristotle who was the one to claim that nature abhors vacuum or emptiness? And in many ways, he's right. He's right to think so. Because how can anything that doesn't exist physically exist? And luckily, there are experiments that could prove that this assumption as it currently is actually not true. So in this video, we are going to prove that it's not likely that current understanding is correct. We are going to look at few experiments that actually question the current understanding, and I will show to you one experiment that should be performed in space, ideally, and that should prove beyond any shadow of doubt that vacuum, this emptiness, doesn't exist. To start with, I would like to tell you my hypothesis about what is vacuum. Vacuum basically is any liquid substance that has been stretched. In this hypothesis, the particles of this stretched substance always hold together to each other or to those others that are surrounding them, and they are always holding strong to any surfaces they are touching. This would excellently explain those experiments with, those big cisterns or tanks. When the vacuum is created or when the air is sucked out of them, they implode. And for this implosion to happen, the power must be enormous. According to current interpretation of science, the force that causes these rail tanks to implode is the pressure of air. But in that case, the pressure of air must be absolutely enormous. It would be much more logical, much more sane, if my understanding, my hypothesis was right, that instead the particles inside the tank are so stretched and they are pulling back. The more you stretch them, like a rubber, the more you stretch the rubber band or something, the stronger it pulls back, and the same is happening in the tank. So what we have to prove now is that these particles are holding together, because according to current understanding of science, particles of liquid substances are freely moving. They are not attached to anything. After all, you can take water and show that you can break it apart, right? It's not holding together. Particles of water are not holding together to each other. The problem is that here we are talking about two different substances that are mixing together, and that allows one substance to be broken into as many pieces as you want. But all of that changes. And for that, I'm going to use an experiment that you all have seen at school. For that, we will fill the glass with water. So it's full now. And let me take a lid from the coffee tub. So if we put this cover on the glass that has been filled with water and turn it around, then the water is not getting out. The problem is Scientists say that it's because of the pressure of air which is holding the water inside. The problem is the water is much heavier than air, and the pressure at the moment of closing it is identical inside the glass and outside. So if nothing is holding that water inside, as per existing theories, as it is understood currently, then the water should, at least some of it, should freely came out. Instead, it stays there. Even if you are trying to use some momentum, some inertia, it fell now, it should have fallen much faster, much earlier out, if the current understanding is correct. This experiment always gives you that bizarre feeling that something isn't right. We know that the air is much more elastic than water is. So no wonder that when the glass is filled with water and the air cannot get inside, the water is holding to the walls of the glass, and the particles of water are holding to each other and to the cover. And this is why it's not falling, because otherwise, what would be the reason for, if this was filled with air? Oh, it holds. It does hold. If it is fully sealed, it holds even with air. Yeah. But the air, with air, there is the same pressure inside and outside, and there is no different weight. But water is much heavier than is the air. So it should be falling, but it's not. We can even leave a little bit of water in. Just a partly filled glass, and leave it like that. Now, I would like to try out another experiment, and that is with a glass bottle. And I noticed this when I was already a little kid, and it felt strange because it didn't fit the description of what science tells us. According to science, if there was no pressure of atmosphere, the water should freely come out. So when I was once at the store, I bought a bottle of lemonade. It was completely full, and I was trying to drink it without letting the air in, and I couldn't get out nearly anything, just a tiny weeny bit. And I recommend you actually try it out home. The problem is, in this case, you cannot use the pressure of the air, atmosphere, as an excuse for water not coming out, because between the atmosphere and the bottle there is your mouth, and you are sucking out it. So you are creating vacuum between the atmosphere and the bottle, and if nothing holds the water inside the bottle, the water should be coming out very easily, but it doesn't. Let me demonstrate you. You have to fully close the opening of the bottle so that no air gets in, and try it. I managed to get out maybe tiny weeny bit, and the stronger I tried to suck, the stronger my tongue was being sucked inside. And it kind of doesn't make sense. However, if you let a little bit air in, and knowing that air is much more elastic than water, you can actually suck some water out of the bottle without letting the air in. But again, it was only a little bit. I drank maybe that much, and it becomes increasingly stronger and stronger and harder to get it out. The question is, if I was able to suck a little bit, why it was becoming stronger and stronger and I couldn't get any more? If most of the bottle, or at least half of the bottle, is air, I could squeeze, I could suck out nearly all the water. The less air there is in the bottle, the less water you'll get out. And if there is no air at all, nothing will come. This experiment, in a way, proves that it is more likely that particles of substances are holding together to each other and to all the walls around them. And this is why we cannot suck it out. Even with the strongest pumps, if it was full with water, like a big railway tank was full with water, you turned it around and were trying to suck the water out from there with very powerful pumps, and without letting the air back in, you would fail, because the water is not simply coming out. So another experiment is, I don't know how many of you remember in old times when we got some cold, when we caught some cold or developed some bronchitis or some other disease, there was something like medical banks. I don't know actually the proper name in English, how they are called, but it was some glass containers that were heated up and put on our backs, and they were sucking out, I don't know what, but they stuck to our skin and they were sucking in the skin. So I could try to repeat that one, because that's very interesting and very telling. So I moistured the skin so that when I put the glass on, it fully seals the air from escaping. And what we have to do, we have to heat up the glass, the air inside. And when we are going to put it on the skin, be careful because it cannot be too hot. But when we are going to put it on the skin, it must be very fast because the air is escaping. So I'm not sure I will succeed with this one. Oh, it has sucked. So basically now the skin seems to be pulled inside. It literally feels that the skin is being sucked inside. Again, according to science, according to current understanding, what science is saying, this is happening because of the pressure of atmosphere, and well, according to this idea, we all are walking bombs. Our bodies are waiting to explode, and only the pressure, high pressure of the air is holding them back. Do you see? It's sucked to the skin. Well, not too strong, luckily. And once again, if my hypothesis is correct, that explains this phenomenon much better than the existing theory. Because otherwise it is as if our skin really, as if our bodies wants to just swell up and really maybe explode or something. And only the high pressure of air is keeping us intact. That doesn't make sense. So the next thing, the last one, that would prove beyond any shadow of doubt that I'm right, would be experiment that can be carried out ideally in space, during spacewalk. To be honest, it was already before pandemic. It was Russian cosmonauts, Russian astronauts were about to do spacewalk It was on 9th of September and 27th of September, 2 spacewalks in 1 month. And they were posting that and telling about that on Twitter. And I asked them whether they might be interested in carrying out this experiment. They didn't respond. And nobody has. I have tried to contact some people in NASA, in Chinese Space Agency, India Space Agency. Nobody is ever responding. They are not interested. This is a very simple and easy to perform experiment. Probably even robots can do them in space, but let alone humans. But nobody is interested, even though this would change everything. So what is the idea of the experiment? So if we got a bag, if we have a bag, it's empty, right? We close it fully, we close this opening fully, and it feels full, right? Now, according to science, you can ask absolutely any scientist. They will tell you that space is empty, and if you try this experiment during spacewalk on International Space Station, the bag would fully collapse because it would be completely empty. Maybe they say there will be few particles or something, but that wouldn't change anything because that would be all the time empty. If I'm right, then if you open the bag like that in space and then closed it like that, it would feel exactly as fully full as it is now. And obviously the different predictions for this experiment are very decisive. Either I'm right or science is right. And this is really very simple and easy to perform, but the consequences of this experiment in science would be absolutely enormous, and yet nobody in science community is interested in it. So what would be the consequences if I'm right? And by the way, I have written, I've tried to write manuscript, and I have sent it to several science journals, and they all rejected to publish it. So what would be the consequences? First of all, we know that there has always been this problem about the true essence of light. What is it? And one of the reasons why science was struggling to understand it was that because of our assumption that vacuum is completely free of any substances. But in that case, the light doesn't have a medium to travel through. And this is why earlier, some centuries ago, scientists were talking about the luminiferous ether, or some mysterious substance that is filling the whole universe like a space-time fabric in a way, and that is the medium for light. But nothing of that was found. Instead, if I'm right that any liquid and transparent substance can be this medium that is filling the space, and this experiment would prove me right or wrong. And if that is true, not only we can explain much better the light itself, we can perfectly explain the wave function of light, we can perfectly explain why it's traveling at that certain speed. We'll be able to explain what are black holes without involving some mysteries as it is now. And what else? Yeah, and even if I'm right, we still would be perfectly able, as I have described that in my book, The True Essence of Vacuum, we would be perfectly able to explain why there is no sound in vacuum, why combustion engines don't work, why items fall at the same speed. All that is explained in that book of mine, The True Essence of Vacuum. And I can't remember right now, but there are many other things that actually are we would be able to explain much better if vacuum would be simply highly stretched substance, transparent substance or not, which particles would be in full contact with each other at all times and with all the objects that they are touching. So there will be no gaps and there will be nowhere, anywhere, a space which could be described as free from substances or a space that physically doesn't exist. And well, if you are new and aspiring scientist, I believe that this is what you should be pushing forward first of all. This is what you should be researching, because that could bring a new revolution in science. Unfortunately, nobody is interested, and sometimes I'm wondering, is science community even interested in doing science? They are happy to make up formulas, just create mysteries like about black holes and string theories and multiverses. Absolutely highly speculative and nearly for certain impossible to test and prove theories. And yet, here in front of you, there is a very simple thing, very simple experiment that could be carried out, and yet nobody is interested. So, do we even have a science community? Or has it turned more into like Emperor's New Clothes community that is actually only pushing forward their ideas and they are completely ignoring facts and they are not interested in experiments that would challenge their existing beliefs? So, well, I would like to know your thoughts and your ideas, and if you think this is worth thinking about and this experiment is worth carrying out, press like and press subscribe, and well, there are many other interesting things and interesting experiments that I will bring up in the next videos. And so yeah, that's all for now, I think. Thanks. See you next time.